Okay, good morning everyone. So myself Devbroto Kumar Das from Dumka Engineering College. Today we will take the subject is control system, and
Good
today we
morning,
will
sir.
discuss the chapter is compensation design in control. Yes, good morning.
Just wait, I am starting.
And today we will discuss the chapter.
Okay, my whiteboard is visible, everyone. Please respond me. My whiteboard is visible. Am I audible? Kamal, my whiteboard is visible.
Yes, sir.
Okay. So let's start. So we have discussed in our new chapter, that is a new module. So that is a module 5. Okay. And in this module 5, we have discussed that is compensation design. Compensation of control system. Okay, so this chapter it is a very much important for our previous. We have to discuss stability system. Okay, so we have discussed in module 2 that is a time constant and error stability system in our control system. Then we have to discuss in module 3 and module 4. There are lots of stability system of control system. That means we have discussed route stability criteria. Okay, that is route array table. Then we have to discuss that is Nyquist criteria. Then we have to discuss also root locus, Bode plot. Okay, and then we have to discuss gain margin, phase margin, and M circle and N circles also. So these are the basic procedure we have to discuss in our previous chapters, previous module for the constant stability constant of our control system. So without compensation, this control system, it is not 100%. You have to tell this system it is 100% stable or not. So this compensation design in our control system, it is very much important. So what is compensation? Compensation is a basically one circuit configuration to much better a system it is stable work or not. Okay. So first of all, you have to know what is the necessary of this compensation. So first, that is the necessary of compensation network. Compensation. First of all, it is required, number one, in order to obtain the desired performance of the system we use this compensating network it's applied to the system in the form of feed forward path gain. 1 minute. Feed forward path gain adjustment. So first we have to require that is desired performance. When you have to design a network that is compensation network of the control system, it is basically applied to the system in the form of to gain that is a forward feed path gain we have to adjust using this compensation network. Number two, it compensates a unstable system to make it stable. So it is basically used to a unstable system. You have to compensate a one unstable system to make it stable system. Number three, a compensating network compensating network it is used to minimize overshoot error. We have discussed in our module 2 there are lots of error that is steady state error, transient response error. Okay, so this compensating network when you have to use in a control system, it is basically reduce or it is minimize the overshoot error. Okay, this is very much important. And number four, this compensating network, it increases the steady state error increases the steady state accuracy of the system. This is very much important. Okay, so those system it is not given to 100% accuracy of your result. You have to use these compensating network to increase the steady state accuracy of the system. And number five, this compensating network it introduce poles and zero in the system thereby cause changes in transfer function. Changes in transfer function of the system. Okay, so this compensating network, it is introduced the poles and zeros of the system, thereby causes changes. Any changes is coming in the transfer function of the system. So these are the basic necessary why you have to use the compensating or compensation network in our control system. Okay, so first of all, in order to obtain the desired performance of this network system, it is applied to the system in the form of feed forward path gain adjustment. So first you have to adjustment using this compensation network for the feed forward path gain. Number two, compensate network, it is required for a unstable system to make it stable system. Okay. Number three, a compensating network, it is used to minimize the overshoot error. So this is very much important for a stable of the control system. Number four, compensating network, it increases the steady state accuracy of the given system. Okay. Number five, it introduces the poles and zero of the system, thereby the causes any changes in the transfer function of the system. Okay, is it clear, all of you? Is it clear?
Yes, sir.
Okay,
Yes, sir.
yes, thank you. So next, what is the method we have to use in our control system? Different compensation. So methods of compensation. So first we have to know that is a series compensation. This is first series compensation. Number two, this is feedback compensation. Okay. Number third, load compensator. Load compensation. Okay, so these are the basic process. These are the basic method we have to design a compensation network. So first, series compensation. Then number two, feedback compensation. Then number three is the load compensation. So first we have to draw the series compensation network. Okay. So first one, series compensation. Okay. So I am drawing a diagram. Then you have to clear the idea. So this diagram you have to know in the first classes. This is the basic block diagram of the control system. This is the input section. This is the one summing point. Then we have to attach one compensator. Compensator. Then the process or plan. This is basically we have to introduce, that is GS. Then finally the output we have to represent, that is the CS. CS is the output of the system. And another one, this is the feedback loops we have to attach. And these feedback loops we have to use it, that is the HS we know. And this feedback we have to connect it across the output to the system to the summing point of the input terminal. Okay, this is the positive, this is the negative. We have to given the also arrow marks, and this is the RS of the input of the system. So this is the basically design of a series compensation network. So this is the input of the system with respect to that is the RS. This is the first summing point where we have to summing one network, that is a compensator network. Another one is the feedback loops, and this is the processor plan. We express that is GS. HS is the feedback path or feedback in, and this is the CS of the output of the system. So this is the basically diagram of the series compensator. Series compensator. So here connecting compensating circuit between error detector and plans. It's known as series compensation. Okay, so this is a connecting compensating circuit. This is a compensating circuit in between the error detector. This is the basically we have to call that is the error detector. That means we have to calculate that is the ES from here. Error detector and processor plan, that is the GS. It is known as the series compensation. Is it clear, all of you?
Yes, sir.
Okay. Next, number 2, this is the feedback compensation. So number 2, feedback compensation. I am drawing the pictures. So first, this is the same thing. Input is coming, first summing point, then another summing point we have to attach, then process or plan, then this is the output of the system. And another one, we have to block here attach. This is compensator. And this compensator, it is attached with this block, this summing point to the output of the system. And another, this is the finally feedback we have to attach. This is the output of the system to the first summing point to the system. This is the input of the system, RS, positive, negative. This is a process or plan. And this is a compensator network. This is a feedback network. So these are the basically diagram of the feedback compensation. So feedback compensator. So when a compensator used in a feedback manner, or pattern, it is called feedback compensation. Okay. So here in this circuit you have to see. So this is a compensator circuit, and this compensator circuit we have to use as here feedback rules, using the feedback rule. So that's why it is called the feedback compensator. Okay. Is it clear, all of you?
Yes, sir.
Next, number 3. This is the load compensator. Number 3. Load compensator. This is the same diagram. This is the input first summing point, then another summing point, then another summing point, then the process or plant we have to draw. This is the output of the system. So first we have to use the same, that is a compensator. Using here we have to use this 3 summing point, that is the RS. This compensation network we have to use this one, to the output of the system. Another one, this is also connected to the output of the system to this network, and feedback, this is the HS, it is also connected to the output of the system and another summing point. Okay, so this is the basically diagram of the one compensator, sorry, load compensator design. Load compensator. So here you can see here 3 junction point we have to uses, or 3 signal input system we have to uses in this load compensator. Each and every, that is the process or plant, first we have to connect that output of the system to the input, sorry, summing point of the given system of the process or plant. Then compensator network we have to uses output to the next one. Another one, feedback, we have to use this the first summing point also. So this is called the load compensator. So we have to write, that is a combination of series and feedback compensator is called load compensation. Okay, so this is called the load compensator, and here you can see So in this load compensator, we have to use this previous one. First series compensator circuit, another one feedback compensator circuit. So that's why it is called the load compensator circuit. Is it clear?
Yes, sir.
Okay. So now we have to go the basically classifications of the compensation network. This is very much important. One question it is also coming in your semester exams. And this is very easy chapters, no difficulty. So this is the classification of compensation. So here are three types of networks we have to discuss or draw. First one is phase lead compensation. Number two, phase lag compensation. And number third, this is combination of lead and lag. That is called phase lead lag compensation network or compensation circuit. So this is the basic classifications of the compensation design or compensation circuit of the control system. Number one, phase lead compensation. Number two, phase lag compensation. Number three is the phase lead lag compensation circuit. Okay, is it okay, all of you? So first, we have to discuss phase lead compensation circuit today also. First, phase lead compensation. Okay, so what is phase lead compensation circuit? So a system which has one pole and one dominating zero. Dominating zero, it is known as lead network. Lead network. So if we want to add a dominating zero in this compensation, so if we want to add a dominating zero, for compensation, in control system, then we have to select lead compensation network. That means this network. Compensation. Okay. So this is the basically lead compensation network. And What is the circuit diagram? So here you can see. This is a capacitor. Register you have to done. This is the output of the system. So this is the input. We express as EI. Current is passing from here, that is the I. Then into this network I1. Another one, it is also I2. This is the R1. This is the capacitor C. Okay. This is the R2. And also current is also I. And this is the output of the system. So this circuit, it is basically phase lead compensation network circuit. Okay. And these are the basically direction of the current into this network circuit. So in this circuit is the phase lead compensation network from the circuit we get. So first we have to return, that is the I1. This is equals to, that is C into, that is a ddt of input of the system, difference between the EI minus EO. Okay, is it clear? This is the I1, it is equal to C ddt of input, difference between the input to the output system. Okay, and I2, this is the I2, it is equals to, we know that EI minus E output divided by R1. This one is the I2. So we know that is I equals to here I1 plus I2, this one, the I1 plus I2. So this equation we have written, this is the d dt, that is the d c into ddt, difference between the input of the output of the system, plus I2 EI minus E output divided by R. Okay, and in this circuit we have to know, that is again total current I equals to, that is equals to here output, that is the output of the system divided by this resistor, that is E output by R2. We know that. Now equating this equation, this one and also this one, okay, from this circuit we have to written so equating above expression, that means previous expression of current is I, we get, that is E output by R2 equals to C into ddt of E input minus E output plus E input minus E output by R1, because previously you can see first I is equal to this one and another one also this I equals to this one, input and output. So we have to equating both sides are equal, that is I equals to I, that means this equals to this equals to. Okay, so we have to written these equations also. Now you have to determine the Laplace transform. So taking Laplace transform of both sides, we get the equation is coming, that is 1 by R2, that is E0s this is equals to 1 by R1 into E is minus E output of a system plus CS EI input of the system minus output of the system. Okay, this is the basically Laplace transform of this equation. So we have to accommodate this equation, this one and this one also. This is the 1 by R2 E output of S plus 1 by R1 E output of S. This one multiplied by this one. Okay. Then also this part, that is E S E output of the system. And here we have to return input system, that is EI input of the system, that is the R1, this one and this one also, that is the plus CS EI to the power, sorry, bracket of system. Okay, so now you have to write this equation, that is the output of the system by input of the system. So this equation is coming 1 plus SCR1 by R1. Everyone please solve in your room. The equation is coming in that pattern. Everyone write your own name and roll number in the chat box also. And Gautam is present.
Yes, sir.
You take a screenshot, okay?
Yes, sir.
So you have to solve this equation. Equation is coming in that pattern. So now we have to written, that is E output of the system, that is the by divided by input of the system. This is equals to R2 by R1 plus R2 this is equals to 1 plus SCR1 by 1 plus SR1 R2 C by R1 plus R2. Okay, so this is the basically classification, sorry, this is the basically expression of the output of the system to the this lead compensation. So in your exam, this question is coming, explain the phase lead network circuit and derive the output of the system. So you have to calculate, you have to explain these equations in the lead network. Is it okay, all of you?
Yes, sir.
Okay. So
Yes, sir.
next class we have to continue another network, that is lead network and lead network. This is very much important. Okay, thanks everyone. So everyone write your own name, roll number.